All right, welcome to the third episode of Electrify Your Artwork. In this episode, we will be looking at endless possibilities. So, this is a three-part series. If you have not got into the episode 1 and 2 where we talk about the basics, please do go and watch it. And we will proceed to episode 3 now. In this episode, we will be talking about modules. Okay? What are modules? The purpose of Arduino with modules, and finally, coding the modules. Okay? What are modules? Do you remember last week when we had to put like resistors on a breadboard and the LEDs and stuff? So, a module is integrated. So, we have all the resistors and all the buttons and LEDs all on one board. Normally, it's supposed to be smaller and simpler and ready to use, so we just plug it in and it works. So here are some examples. This, if you remember, I showed this. This is a temperature sensor. So if you can see closely, I'm not sure if you can, but these tiny things, they are resistors. Okay, extremely tiny. A potentiometer or a variable resistor, the sensor right there, and it only comes with pins in, out, and the output or the signal. This one is volume control. Is it volume? I think it's an amplifier. I don't recall. But you can see it has all the transistors, resistors, the little potentiometer or variable resistor, and the pins are all clearly put here. Easy. The other type, one more example would be the LCD screen, which we'll be featuring and using today. The LCD screen comes with a lot of things and components itself, and itself is a module, but this one comes with an added module called the I2C. It basically controls the brightness and all the signal in and signal out, all these pins down to just 4 pins. Okay, just makes everything easier and neater. If not, we would need a lot of wires. So, where do we use the modules? We generally use the modules at the input and output side. Modules interface with the Arduino, which is the microcontroller. So modules act as an easy way to get input and also produce or show the output from the brain or the Arduino. Okay, so like in this picture, we have a ultrasonic sensor that we used last week, and we have the Arduino as the brain, and we have the LCD screen as the output. All right, we're going to use this and make this thing later, okay? All right, now I want to show you how we connect the modules. Done this earlier, but let's try again. Reset. We have 4 pins here. The top one is ground. Second one, VCC or the 5-volt in, SDA and SCL. Okay, so on your board, SDA and SCL are the top 2 pins. SDA the second pin, and the top pin would be SCL. Mine is indicated. However, if yours is the original Arduino, it will not be printed like that. So let's connect. I got this new jumper cable. Gonna connect everything and separate them by color. Okay, they're in. Okay, so let's see. I want to connect them the other way around actually. Let's do as ground. It's always nicer to have darker colors as ground for me. In here, in, plug in. So blue goes to ground and green goes to 5 volts. So we have 5 volts here, ground here, 5 volts. Okay. This side, let's put orange is SCL and yellow SDA. So second one should be yellow. Top is okay, let's see. SDA yellow. Checking. Yep. All right. Now I have already coded this. I already pre-programmed it. So we'll just plug in the power and it says, hello everyone, Ali. Okay, this is on loop, so it kind of erases itself after the loop is done. And with the back part, can use a screwdriver to adjust the brightness. Right? Okay, that's perfect. See? Easy. Only 4 cables compared to the previous one. Way easier. Hey, welcome back. We are now at Tinkercad. Okay. If you remembered, this is Arduino simulator. Really easy to use. So I have connected all the cables like the previous example, real world examples, and we'll go through the code. This time I'll be using the blocks, the easier for us as beginners if we use blocks. So first thing, we have 2 parts, right? The start or the setup and the loop. So first thing, we need to define what we want. So I want to use L, yeah, LCD, right? Configure LCD. Name is 1. Okay. Next, I want to print something on the LCD. So let's look for set position. And it's optional, but I prefer to put it nicely. We have 2 rows here. So column 1, of course, the first place here, and the row, first row, so row 0. And I want it, okay, so let me explain why 0. For everything in the computer world, first thing is always 0. Okay, starts at 0 and 1. So we have to put row 0 there. Put row 1, it will be the second row. Okay, okay, and then we will print something. That's the print function. Print LCD1, that's 1. Print hello world. Okay, let's try it. Boom, hello world. Easy. Just few lines. Code. Let's look at the code. Just few lines, not hard. So now I want to show the second line with a smiley face. So I added in this code, column 1, row 1, print to LCD, smiley face. Let's try it. Now that we have connected the LCD and made it work, we will be adding in the ultrasonic sensor from last lesson, and we will try to trigger the screen, show something as people walk nearer to it. Okay? I connected it all, ground, 5 volt, signal into, and this one SDA, SCL, and ground and voltage. Let's look at the code again. So code, for the code, we have 2 loops again. Sorry, 2 parts again. The loop and the beginning for the setup. And we're gonna put the configure LCD thing again. LCD want to type blah 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 32. Let's check it. Address 32. That one. Right. Next, we want to print something. So um set position one row thing. Let's just keep it as hello world now. Thing. So okay. In. Okay. Right. Now this code was just like before. It just showed something. But we want to add in an if function. Okay. If something, then this thing happens. So we can put that in there. Let's see what we can. It's definitely an input, but I have a diamond shape here, so I have to put diamond. I want to use this. If less than something, something less than something, then the code will run. I put it at less or equal. Yeah, we got the ultrasonic air read ultrasonic sensor on trigger pin 2. Echo pin is the same as trigger. M less than, let's say, 50 meters, and run the code. Test it. Running, saying hello world. Okay, it is less than 50 centimeters right now. More. Oh, I forgot to add the clear function. Let's do that. Have to add in the clear function. 1 second. Here, this work. There we go. It's not printing. Go closer. Less than 50 centimeters, it prints. Clears it. Clearing too slow, so I want to change it to 5 seconds. Right again. Okay, hello world is a bit too polite. Let's say too near. Shock face there. Face. Right. Too near. Scary face. More than 50 cm, nothing happens. Nearer, triggers. Still further. Okay, it's triggers now. Okay. However, now I want to show the actual reading of the ultrasonic sensor. So I can use the same function, alright? Read. So I'll put it on column 2. I'll put it here. I don't want to print the funny face. I want to print the distance. Well, let's try. Sure. Distance. Printing. Oh, wrong pin. Gotta adjust that pin to too near. Okay, 37 centimeters. Move it further. It's a print. Comes near, it prints. Okay. So there you go. You can always replace this with a motor or another type of module like a power supply or relay. Relay, yep. A relay will trigger a switch because some projects require more power than just the Arduino 5 watts. Let's say I want to run a very powerful motor and there's not enough juice on the Arduino board. So I would need to use a relay, plug it here, and same, it triggers like this code. You can just change this to a trigger instead of print if less than trigger. Okay. And then when it triggers, the motor ons, and if it's not, it will turn off. Okay. For that function, we can use if or else, or just use the if and then function. Okay. Stop the simulation here. And that's it. Easy. That's the end of the lesson. And now I want to talk about some tips and tricks. Okay, for the first tip, already been hinted, a lot of the code that you need can be just copied from the internet and modified, or you can just use Tinkercad and play around. However, Tinkercad, sometimes the code doesn't really match. So if you have further interest or you are excited to the point that you have ability to self-learn or self-study coding, then you can just proceed to the Arduino IDE. Okay, the one that you can type direct text with. And let's look at this website called Instructables. So on Instructables, we have a lot of examples. Okay, for the Arduino, it is under Arduino. So we have power supply current meter. I'm not that. Oh, not really. You can just search or look at the cool ideas. Wow, there are a lot of easy new ideas. Sun humidity sensor. That's interesting. An artwork. Um, Bot maybe robot. Yeah. Pac-Man goes LED matrix. Definitely usable in artwork. Self-balancing. Maybe. Interesting stuff. So there are plenty of examples. Most of it is just like click on it. It comes with a list. It comes with a list of things you need to buy. You could just use an Arduino. All Arduinos, Nano Plus, they're just different sizes. The water level sensor or soil sensor and blah blah blah. Don't need to print the box testing it. And yeah, they give you the whole circuit diagram and definitely the code. Boom, just copy, change the values that you want, and just play with it. Can even like copy half the code of this and add in another code. Let's say I also want to calculate sunlight, so I add in a light detector or light sensor and add in the code. Okay, the second tip is when we use a lot of our artwork, it's best to isolate things, as in the controller sends the signal to the switch. A relay is a switch, right? So the relay takes in the Arduino output that says turn on until I tell it to turn off. So it turns on. And this one you can put like depending on the thing. So sometimes it can go up to, okay, this, oh, it says here. It says 10 ampere and 28 volts. Okay, so can pump in 28 watts and power a very powerful motor, or let's say a big screen or something like that. Okay, sometimes this goes up to like 300, 240 household things. And of course, look at the price. A normal Arduino costs about 100 ringgit, and the local ones really useful. Setting up a bit difficult. You need to download the drivers, but once you do that, plug it in, install the drivers after you plug it in, and it will work. And you can just look at the whole ecosystem they have for Cytron. All right, it's a local company, and I like it because it's cheap, so I can buy many. And I tell you what, these things, um, so cheap, right? So you just buy one, plug it into your project, and then you buy another one. So it's nice to keep like one spare one at home for prototyping and have maybe for three round two so that you can have two projects going on simultaneously. Tips for coding. Okay, I don't want to get to that. I think it's easy to use Tinkercad for now. Just play with the blocks, get interested, and it would help you learn text coding later on. Or you can also look at the text part and just copy paste into the Arduino IDE and upload. Okay, this one is a bit different. It comes with the particular model from this brand called Idea Fruit. So this was it. And okay, if I just put it to text, everything was fine. I can look up libraries. Libraries are like shortened code packed into it. So in this one, we did use this code, I think, or the other fruit. Okay, we use this one. So it's already included in there. It's like just type that hash include and then boom. Every time you call the function, it will register as that code. Okay, so the last tip is probably something you've seen before. I have this plastic thing that comes with little mounts. They come with screws already. So I just screw on my Arduino there once, and every time this is my prototyping one, and every time I just plug it in because it's easier to plug things in and test things when they're all secured down firmly. It even comes with little rubber dots. So this one is easy to use and it also widely available on Shopee or local shops and stuff. Okay, where do you find these electronic shops? Uh, I normally get my stuff on Shopee. Or Citron. It's easier to get online than to go to a shop and wait your turn and don't know what to get. For the resistors, I always have 1 kilo ohm resistors around, lots of them, and 10 kilo ohm, and that would do for a lot of functions. Yeah, everything else, lots of LEDs. Yeah, switches, LEDs, lots of ultrasonic modules, infrared modules, and stuff like that, just for keepsake and experimenting. So today, episode 3, we went through adding modules. Okay, we looked at what are modules. Modules are integrated boards with all the components you need, all in one tiny space with as neat as possible a layout. Okay, all ready to use, just plug it in and it works. Um, the purpose of the Arduino is to interface or be the brain to the modules. Modules can be input or output too, and we also learn how to code the modules to interpret the signals that we get and to show things on the output module. Okay, and I hope you have interesting projects in mind and let your creativity run wild. Learning coding is quite interesting and requires a lot of trial and error, but it's very satisfying. And I hope you enjoy your 3 classes with me. Once again, I would like to thank Romule, My Creative, and Cendana for supporting this project.